G'day, how you going? My name is Harry. These are my colleagues, John, Stevo, and Kush, and we are Team 7. And we pitch forward to you our idea, an effective, modern, and simplistic version of a currently used Elliott trap.
Yep, alright, so currently there's an ongoing research on sugar gliders where an Elliott trap is utilised high up on trees. However, because the current state of the trap is purely mechanical, volunteers are required to climb up the trees using ladders to manually check if the trap has caught anything. Not only does this risk the safety of the volunteers, it is also very time consuming, especially if there are more traps laid out than volunteers. Therefore, our project idea consists of modifying an Elliott trap to be able to detect if a creature is captured with the use of multiple sensors and a wireless remote. This will help the user confirm if the trap has been set off and could prevent the unnecessary effort of having to check each trap manually, subsequently saving a significant amount of time. The improved trap will consist of a weight sensor, a motion sensor, a radio module, a high torque motor, and depending on the success rate, potentially a camera. The purpose of the first two sensors will be to confirm that a creature is captured inside the trap and it wasn't accidentally set off. The radio module will simply be to connect to a remote a user will have down on the ground, which will consist of 3 LEDs, red, yellow, and green. The user will point the remote towards a trap location and the color of the LED will determine the current state of the trap. Red for trap not set off, yellow for trap set off but no creature caught, and green for trap set off with creature inside. If the current state LED, the motor will be activated to reset the trap autonomously, hence removing the need for a volunteer to manually climb up to the trap. The price of all the components added to the Elliott trap is approximated between $25 to $45, with the cost of a camera included. Therefore, that brings the total price of the new and improved trap to be between $57 to $75 per trap.
Although our product is predicted to cost more than what is currently on the market, our team believes with some innovation, our product has the potential for a very successful product lifecycle. Our product will initially focus on the overall improvement of the Elliott trap design. However, if our design is perfect, every potential customer would only need to buy one of the product, and this will very quickly dry up the market for the product. In preparation of this, our team has begun thinking about future phases for the project, including product maintenance and spare components for the product. Over time, components will fail, and it is important to offer cheaper solutions to customers other than a full replacement of the system. Further improvements to the trap must also be considered for future phases. Potential improvements may eventually extend to the automation of traps for many different animal species, expanding the product's life cycle even further. The aim of the product is to improve the overall efficiency of the Elliott trap. Being more efficient will save many research dollars and many man-hours. The remote and automated trap aim how far volunteers must travel to check if a trap has been triggered. This will massively reduce the amount of fuel and time needed to reach each empty trap. Reducing how often people are near the traps may also reduce the effect the research has on the surrounding environment, making the product more environmentally friendly. However, reducing the fuel used to reach and check empty traps will already massively improve the impact the product has on the environment.
Before the product was developed, first we needed to identify our target audience, their problems, their desires, and most importantly, whether they would use our proposed solution within their field of work. To do this, we have a variety of promising potential customers, including Southeast Queensland academics, environmental research and conservation organisations, and local councils, pitching forward our idea, our intentions, and asking for honest feedback. Proposed questions of interest included whether Elliott traps are currently used in the field of work, whether they believed the idea was good, and most importantly, whether or not they would buy our product. We also inquired whether they knew others interested, expanding our initial customer scope beyond our product vision. As graphically illustrated, around half of contacts responded positively to the proposed idea, even addressing preferences of how it could solve problems personally encountered. Based on this, we concluded environmentalist groups as our most promising customer, shortly followed by academics and councils, with their most prominent and overlapping problems identified and listed above.
Upon analysis of the current costs involved in data collection, it is apparent that the primary cost is to workers conducting the collection of data. Maximizing utilization of a trap requires consistent checking of the trap, which can be impractically expensive for organizations to afford. This either results in a bottleneck in research due to slower data collection or more expensive project costs than is necessary. Bottom line, both are poor outcomes that can be mitigated through the implementation of our automated Elliott trap. The automated Elliott trap will be a more expensive on a per unit basis due to the nature of this being a retrofitment of the existing Elliott trap. However, as previously discussed, the costs are primarily through having employees managing the traps. Through the implementation of an automated trap, the time required to maintain, sustain, and operate these traps at their most efficient and effective, fully utilized state is achievable with much lower overheads. As a result, the effective data size to operational cost, including upfront cost of the traps, will be much higher. The significance of this improvement will be dependent on the ability to use the new capabilities effectively. As a result, we will be additionally providing support in trap network to suggest ways that will allow for maximum utilization for each specific scenario. Generally, it will be found that current employees checking the traps will be able to be put onto a less intensive checking regime, with them only being called on site when necessary to remove travel time, employee working time, to prevent checking empty traps. Personalized solutions don't come from designing products in the dark. We have liaised with industry to pinpoint current issues with their Elliott traps and walk them through some of our proposed solutions. An example of this was the labor intensity of climbing trees to checking empty traps, release of unwanted animals trapped, and resetting the trap. This was addressed with the design of a release mechanism allowing a worker to remotely open the trap, releasing unwanted animal. Doing so also resets the trap for continued use. Feedback regarding this solution was very positive, with strong anticipation to trial our final product. Current market for automated traps were researched and found to be currently available. These competitors were analyzed as to their target audience as well as their current product similarity to our product. These organizations were justified as either not selling similar products commercially or selling less relevant products. For instance, an organization called Western Trapping Supplies commercially sells IoT traps. However, these traps are predominantly for pests such as wild dogs for farmers and not for catch and release of data collection. As previously discussed, automated traps have been developed and there is a market for these currently. However, catch and release specific products have not been commercially sold for data collection purposes.
To conclude, current Elliott traps are an outdated method wasting time, money, and other resources throughout its operation. Our product will rectify problems both we and our customers identified, repaying your investment through immediate improvements and effective results.